Well, hello, this is Jack Jackson. This is the College Algebra Practice Test 3B. This is going to be the first of a series of videos that's going to go over the questions in this exam, or practice test. Probably break this up in about a few parts, probably 3 parts. So here we go. We'll start with question number 1. 4 times the square root of 75 plus 8 times the square root of 27. Break 75 down as 3 times 25, so it's 3 times 5 squared. And the 27 is 3 cubed. The root is second root, so we're dividing the powers by the root here. Power 1 is already less than the square root, than the second root, so it stays inside. 2 divided by 2 is 1, so the power 1 goes on the outside. Normally that would have absolute value, but the absolute value of 5 is 5. So the value of 5 is 5, 4 times 5 is 20. So that's the first part. 3 divided by 2 is 1, remainder 1. So when you're dividing the power by the root, the quotient power is power outside. The remainder power remains underneath. It should have absolute value. The absolute value is 3 is 3. 3 times 8 is 24. These both have a square root of 3, so we can factor that out and just add the coefficients. That's 44 square root of 3. That's the correct answer over there. And so we can see that's reduced. It's pretty clear that can't be broken down any further. One way we can sort of check this if we have a calculator is do 4 square root of 75 plus 8 square root of 27, and we get a decimal there, 44 square root of 3, and those decimals match, so that says at least these are equal to each other, and since this one is reduced form, we know we're in good shape. Some calculators will actually work this out if you have a CAS calculator. Next question. 8 square root of 3 plus square root of 5 square root of 3 minus 10 square root of 5. Okay, do FOIL. Multiply these. Square root of 3 times square root of 3 is 3 times 8 is 24. Square root of 5 times square root of 5 is 5 times negative 10 is negative 50. That's the square root of 15. Multiply what's underneath. Square root of 5 times square root of 3 is also square root of 15. And then we multiply the 10 times 8, negative 10 times negative, or positive 8 is negative 80. Here you can factor out the square root of 15 and do 1 minus 80 is negative 79. And we can add the like terms here as well and get 26. And so we get this, negative 26. It's bigger. And I believe that one checks out. So let's just check it out with the calculator real fast. Negative 26 minus 79 square root of 15. There's a decimal approximation. Now let's do the other one. 8 root 3 plus square root 5, close parentheses, open parentheses, square root 3, close parentheses, minus 10, square root 5, close. And do we get the same decimal? Yes, we do, so at least those are equal to each other. Looks like we got that one right as well. Moving along. Next question. Cube root of 250 over 9. I'll break this down. 9 is 3 square, and so we've got a cube root of 3 square there. We also have the cube root of the 250. Okay, let me go off to the side here. 250 is 10 times 25. 10 is 2 times 5. 25 is 5 square, 5 times 5. So altogether we have a 2 and a 5 cubed there. Okay, now what we want to do is we want to multiply the numerator and denominator here by the same amount. and it needs to be, if it's a cube root in the denominator, when you get a cube root in the denominator, you've got to multiply the top by the same thing. Down here we'll multiply what's underneath the radicals and get a cube root, but we want them to go away by the time we're down in this last step I've written here. So that means in the step right here, we need the powers to be multiples of 3. So we have 2, we need one more 3 to bring this up 3 to the third power. Then the cube root of 3 cubed will just be 3. Well, that means I have to multiply the top by the cube root of 3 as well. So the top becomes then the cube root of 2 times 3 times 5 cubed, and the bottom is cube root of 3. Simplify these radicals. The bottom one I've already done. The top one, I can't do anything with the 2 and the 3 here, but the 5 cubed and the cube here cancel, leaving a 5 out front. And we're done, except we need to, don't write that as 2 times 3, write it as 6. And we have rationalized the denominator there. Okay, again, let's just check this on the calculator. Now, on the calculator, you're going to need to check this with fraction powers. So we're going to do 250 divided by 9 to the power, parentheses, 1/3, and get a decimal for that. And then we'll do the decimal for what we have here. Parentheses around the numerator. 5 times 6 to the power 1/3, and divide by 3. Since those are the same, we know at least that we've got something that's equal, and hopefully this is the form that they're looking for, which is a reduced radical in the numerator, no radicals in the denominator, and that's what we have. Checks with what they have here, so we're good so far. Now we're on question 4. More manipulating expressions here. So 8 over 9 minus square root of 10. Here, this technique that we used in number 3, or when we have a single radical, we could multiply the same technique like this. Here again, we're going to multiply top and bottom by the same thing, but we use a different technique. We're going to be using the technique of the sum and difference pattern, that a plus b times a minus b is a squared minus b squared. The o and the I, the FOIL, cancel out. So this is 9 minus the square root of 10, so we put 9 plus the square root of 10 here. The idea here, according to the directions, are to rationalize the denominator. Okay, so what does that give us? Well, in the denominator, that gives us 9 squared minus the square root of 10 squared. 9 squared is 81, square root of 10 squared is 10. So when we get down here, we're going to get 71, a single number without a radical in the denominator. Now on the top, actually I'm going to probably, I think it looks like they want us to distribute this. So 8 times 9 is 72, and then you've got 8 square root of 10. And I believe this, there's other ways we could write it, but I believe that's the form they want us to write it in, and it looks like that's correct over there. And again, I could double check that at least this was equal to that one by typing both in the calculator. Why not? Let's check that. 8 divided by parentheses 9 minus square root 10. There's a decimal approximation for that. The other one, parentheses around the numerator, 72 plus 8 square root 10, close, divided 71. Same decimal, so at least that's at least those are equal to each other and hopefully in the right form. Next, number 5. Okay, we've got the 4th root of the 3rd root of 2. Well, you multiply these two things here to get the 12th root of 2. The reason why that works is the 2 on the inside is the 1/3 power, and then outside of that you got the 1/4 power, and our property of exponent says you can multiply those to get the 1/12 power, which then you can write that way. And that's, we have that there. Next question. 6. Complex numbers. 14 plus 6i minus 5 plus 3i. Just distribute that, get rid of the parentheses here by distributing here, so minus 5 minus 3i. Combine like terms, 14 minus 5 is 9, 6i minus 3i is plus 3i. And you can do that. Your calculator will actually do complex number arithmetic. So you can do this like on the calculator. 14 plus 6, and I is, I gotta find it, I'll use this a lot. Okay, where is it? I can't see if that's it or not. Is that it? No, that's not it. Should be right here on the keyboard somewhere. I just don't see it. Yeah, there it is. It's just hard for me to read this keyboard. Okay. Okay, so it's 14 plus 6. I is second in the decimal. Okay. And then minus, parentheses, 5 plus 3i, and that will compute that correctly, 9 plus 3i. Square root of negative 16 times the square root of negative 4. I'll do it by hand, and I'll use the calculator both. 16 is 2 to the 4th. Think of it as negative 1 times that. 4 is 2 square, and then we got negative 1 times that. The square root of negative 1 here is I. The square root of negative 1 here is I. Square root of 2 square is 2. Square root of 2 to the 4th is 2 square, or 4 in other words. You might just know that 16 is the square of 4. 4 times 2 is 8. I times I is I squared, which is negative 1. So the answer is negative 8. Again, your calculator can do this one directly. Square root of negative 16 times the square root of negative 4, if you just want to type it in like that. Okay, non-real answer. Okay, so that's okay. We can fix that. What we do is we go to mode, and when it goes down to down here, instead of saying real, put it on A plus BI. Okay, and once we do that, if I pull up my last entry, it will figure it out, even if it involves some i's. Okay, so negative 8 is the correct answer. So even though the final answer was real, there were some i's in the process. Okay. 2 plus 4i, 5 minus 6i. We do FOIL. 2 times 5 is 10. Let's do this part next. 4 times negative 6, negative 24, I square. Here we got 20i and negative 12i. Combine here to get 8i. I squared is negative 1, so this becomes 10 plus 24, which is 34. This was positive 8i. So there's the correct answer, and again, the calculator can actually do this. So if you want to just do it on a calculator, that works. 2 plus 4i, 5 minus 6i. And of course, you have to have that A plus BI thing turned on, but it does work it out correctly. (5 over 5 minus 11i). Okay, to do it by hand, we want to multiply by the complex conjugate in the bottom. In other words, the other half of the sum and difference property. So this is the difference part, so we need the sum part here. Have to multiply the top by the same thing as we do in the bottom. And so we get a difference of 2 squares in the bottom. Now look what happens here. 5 squared is 25. 11 squared is 121. I squared is negative 1, so that changes that negative to a positive. So when the dust settles, we get 146 in the denominator. Now we do FOIL in the top, which is 25 plus 55i. And then we distribute this 25 over 146 plus 55 over 146i, and then we reduce these fractions if we can. We can't in this case, so there's our final answer. Now we can do this on the calculator as well. Let's see. We do 5 divided by parentheses 5 minus 11i, and it'll give it to us in a decimal, but if we go to change to fraction, math, and then number 1, so and enter, there's 25 over 146 plus 55 over 146, and then times I. So okay, I to the 8th power. Well, I to the 8th, you just divide the power by 4, and the remainder is the power that it's equivalent to I to that remainder power. I to the 0 is 1, so the answer is 1. And again, the calculator will do that. I to the power 8. It is 1, but look what it gave us. It only approximated it. This is 1 minus 2 times 0.0000, 12 zeros and then a 2, I. So really this should be 0, I here, exactly. So this is a little deceiving here. So there's one where you might want to do it by hand. It actually is 1 exactly. This is approximately 1, but has a small imaginary part which is not correct. So somehow the way it's doing its approximation is not so great. Okay, 11. Okay, we got a piecewise defined function. Now, if we want to evaluate these things, it depends on which part of it, the problem it is. So h of negative 7, well, which of these parts is it? Well, negative 7 is the part that is less than negative 5, so we use the formula negative 3 times x minus 11 and plug in negative 7 there. So it's positive 21 minus 11 is 10. Okay. H of 0, 0 is in the middle piece, and that makes y is 2 for all the x's between negative 5 and 2. H of 2, alright, let's be careful, this is on the boundary, it's on the last piece, so we use the formula x plus 4, so that one works out to be 6. H of 6 is, well, it's in the last piece too, where x is bigger than 2, so it's x plus 4, so that one turns out to be 10. So, in this kind of problem, piecewise defined function, the formula you use depends on the kind of x that you have for the input. There are 3 different choices for formula based on which of these conditions are met for x. Another piecewise defined function. Okay, let's make a little bit of a table here. F of x equals negative 1 minus x, negative 5 plus 2x. This is first part's if x is less than or equal to 2, and if x is greater than 2, we use this. Okay, so let's take a look here, and let's make a little bit of a table. First of all, let's check some boundary points. If you plug in 2 here, in this one, you get negative 1 minus 2 is negative 3. If you plug in 2 here, you get 2 times 2 is 4, minus 5 is negative 1. this one is included, so this will be a solid dot boundary point. This one's not included, so this will be an open dot boundary point. Okay, so let's make a little bit of a table for x's and y's here. So for the first part here, we want to choose x's that are less than or equal to 2. So negative 1, 0, 1, and including 2. For the next part, we pick up x's bigger than 2, 2 point anything, up. So we'll just put some 3, 4, 5, 6. Okay, so let's try some numbers. Let's put 0 in here. You get negative 1. This has a slope of negative 1, so this will be negative 2, negative 3, negative, 0. Okay, so, alright, that looks good. And here, let's try a 3. That's 6. Minus 5 is 1. This one is a linear with slope of 2, so this would be 1, 3, 5, 7. We could just check some of those out. And so we could graph this. Let's go over here. Okay. 2, 4, 6. Like this. Okay. So notice 2, negative 3 is going to be a solid dot, and that's a boundary point. The 2, negative 1, write the 2 up here. The 2, negative 1 is an open dot boundary point. 3, 1 is here. 4, 3 is here, and so forth. And so this one is going up like this forever to the right, but it comes back to the left all the way down to, but not including the point at the boundary there. This one here has a negative slope, so 0, negative 1 is right there. 1, negative 2 is right here. Negative 1, 0, and so forth. And so this one is going back this way forever. So that's what the graph looks like. So let's see if we can match that graph up to one of the ones that's there. Looks like the only one that's a possibility would be B. So B is the correct answer. It is possible to get there's a couple things you can do with the calculator that might help with this. 2 ways you could do this. You could let this one be y1 and this one be y2, and then you're going to get a line. You're going to get 2 lines. You'll get a line here and a line here. Okay, and of course this line only goes to a certain point, and this line only goes to a certain point. So that's not really part of the graph. That includes the graph, but it includes a lot of extra stuff too. And you could use the tables to help you graph, and then you have to by hand go over here and just get to the right part, or graph the whole thing and then erase the parts that don't need to be there. You can actually put this in the calculator and get it to graph correctly, but it's a little bit tricky. I don't know if it's worth the effort, but let me show it to you anyway. Put in parentheses negative 1 minus x, and then put the condition that x is less than or equal to two. Notice I got the less than and equal to from the test menu, which is second math. And then plus, then do the, in parentheses, the other condition, negative 5 plus 2x, close parentheses, and then parentheses, put the condition x, again test, greater than 2. And now if I graph this, let's see, we'll just do zoom standard. You will get the right thing. If you trace it, particularly at 2, notice that 2 is in the bottom piece there. That's where the solid dot is. But if we go even just a little bit to the right, we go on up to this other piece there. So that is possible. And then you can look at the table here as well, and that generates the table that we just looked at. So that is possible for that to be done, but again, I'm not sure if it's worth the hassle. It may be easier just to do it by hand. Okay, so we have x squared plus y squared equals 5. Okay, determine the symmetries. Probably the easiest way to do this is to do it with by checking it out algebraically. So if I take x to minus x, that'll reflect about the y-axis. And we reduce or simplify this. So notice that when the dust settles, these are the same. So we reflect about the y-axis, nothing really changed. So yes on y-axis symmetry. Okay, let's check for the other symmetries. How about so we're going to reflect over the x-axis, and that's for changing y to minus y. So because of the even power here, this is the same as just y squared. So again, it's the same as the original. So yes on x-axis symmetry. And to do origin symmetry, you rotate 180 degrees about the origin, and that's going to change x to minus x and y to minus y. And so when we do that, it turns out to be the same as well. So yes on origin symmetry as well. So it has all three. Okay, describe how we can get this graph from the original. So the original is f of x equals x cubed. So basically we know what that looks like. It looks like that. Okay, and we can do this in stages. It looks like the first thing they're going to do is a vertical stretch. So that's the 1/3 vertical stretch or shrink. That's the 1/3 there. But this is the same as, well, let me leave this y equals x cubed. And so this is y equals 1/3 x cubed, or 3y equals x cubed. So we see we've replaced y by 3y, so you really make it 1/3 as tall. So it's a vertical shrink. Okay, so now we're down to either B or D. So now it's still similar, but it's shrunk a little bit. So factor of 1/3. So it's 1/3 as tall. Then the next thing is we take this one and we go to the final, which is y equals 1/3 x cubed minus 4, which in other words is y plus 4 equals 1/3 x cubed. So again, from here to here, we're changing the y's. Replace y by y plus 4, so what we really do is add, subtract 4 from the y's, so that's a shift or translation down 4. So shrink and shift down, that's D. And so we take that last graph now and simply shift it down. So it should be down here. This should be at -4, 0, -4, and it should look something like that. And so there, A is the only one possible there. Next question. Okay, this one we're doing from a graph, and we want to, they didn't give you a formula, but they want to do, so they first graph y as f of x, and now we want to do y equals -3 f times f of x, or -1/3 y equals f of x. So we've done two things. We've replaced y by minus y, which is going to flip it over, and then also y by 1/3 of y. So what we're really going to do is multiply all the y's by, well, by -3 if we want to do it in one step. So this one, let's look at our scale here. Okay, be careful, this is 18, so these two each, 2, 4, 6, 8, 10. Now what are these 3 each? 3, 6, 9, 12, 15, 18. Okay, so these are 3 each. These are 3 each here as well, so these are 3 each. So this is 3, and we multiply by the y by negative 3. It's going to now go on the other side of the x-axis, reflect over, and then 3 times as far down. So instead of 3, it's going to be at 9, which is 3, 6, 9, should be right there. Okay, that alone tells you it's got to be this one right here. See, but it should be upside down. So it goes, this one goes down, up, down. This one will go up, down, up. The points on the y-axis don't move. I mean, on the x-axis don't move, excuse me. And then they're fixed points, and then it's stretched out 3 times as tall. So let's see. Okay, I think we'll pick up with 16 on the next video.